Hello everyone, welcome to lesson 9-1, functions. For more references, please look at pages 384 to 389. Let's look at example 1. But before we do, what is a function? Well, a function is a relation in which each element of the domain is paired exactly with one element of the range. Domain, you can see it as your x. Okay, so we are going, if we were graphing, this would be your x. And this would be, your x-axis, and your range right there would be your y, okay, your y-axis. The domain contains all values of the independent variable. These are variables. When they're independent, we choose these variables. Are we choosing apples, oranges? Are we choosing time? What is it that we're choosing to measure? Okay? These values are chosen and do not depend upon the other variable. The range, now this is what we're measuring. So the domain is the things that we're measuring, and the range is the measurement. The range contains all the values of the dependent variable. These values depend on the values in the domain. So a function means it has to have, let's zoom this in. A function means that for every number that you have in the domain, you have a corresponding number in the range. Okay? For every number you have in your x, you have a corresponding value in your y. So you can see that here, it says it here, this is a function because each domain value is paired exactly with one range value. Now let's look at this example of not a function. This is not a function because you see the domain 2 it's being assigned two values. This is not a function because 2 is in the domain is paired with two range values, 1 and 3. So this would not work. For example 1, determine whether the relation shown in the table below is a function. Okay, so we have our domain and our range. In our domain we have 9, 11, 13, 17, 51, 21. And in our range we have 7, 3, negative 1, negative 5, negative 7. And you can see that each one is being paired exactly with 1. So yes, this is a function. Now, we're not talking about a proportional relationship or anything like that yet. We're just seeing if it works to be graphed. Yes, it is a function since each domain value is paired with only one range value. So, number 1, determine whether the relation 5, 3, negative 5, 4, 4, 2, and 4, 1 is a function, and explain. See, these are ordered pairs, right? They're coordinates. And we have x, y, x, y, x, y, and x, y. I'm seeing that for every x, I have a y. For every domain, I have a range. Do you see that? For every domain. So, is this a function? Oh, look carefully. Look carefully. We see that y, x here is 5. And over here is negative 5. So these are both different numbers. Okay. But then when we look here, we see that 4, x4, and we see over here 4 again. It's being assigned two ranges. This domain, the domain of 4 has 2 and 4 has 1. This cannot work. You cannot graph something like this. So, no, it's not a function. Well, why not? Remember what I just said here. The domain value 4, let's just see here, the domain value is paired with two range values. It's paired with 2 and 1. Okay? Please copy this down. Number 2. Use the table below that shows the cost of gas in different years. Is the relationship a function? Okay, so we have the year that we choose. This is our domain. Okay, we have 1, 2, and 3 different domains, and 1, 2, and 3 different ranges, and they're each paired up with 1 exactly. So it fills in our definition. It follows our definition. So yes, it is a function. Each domain value is paired with only one range value. Okay, boys and girls, I think you can tell we did the independent practice together. Okay, that's it for lesson 9-1. Make sure that you did copy it all down and that you understand it, because you will have questions exactly like these in your exercise slip. Part 2, lesson 9-2, representing linear functions. For more references and examples, please look at pages 390-395. Let's look at example 2. Find 4 solutions of y equals negative x plus 1. Write the solutions as ordered pairs. Now remember, X is our domain. Okay, right there. X is our domain, and our domain is chosen, right? So we can choose what we're going to make our domain. And Y is our, so this is our independent. Okay, this is our independent variable. Our domain is our independent. Don't forget that, because we choose it. It's independent. But whatever we make this will change the value of Y. So Y is dependent. Okay, so our range is dependent on whatever we make our X. So choose 4 values for X and then solve for Y. So we're going to choose 4 values for X. Any values. Look at this. They chose -1. They chose 0. And I know they're writing -0, but there's no such thing. -1 and -2. Okay, so 0 plus 1 is 1. Okay, that's what it's going to give you here. -1, okay? But remember, it's negative times a negative makes this positive 1. So if you take away a negative, it's actually giving you a positive. So positive 1 plus 1 is 2. -1 plus 1 is 0. -2 plus 1 is -1. And then all of these will give you your value of your range. And then you have your order pairs. Okay, so these are the numbers we chose. And then we just replace the variable X, and we have our ordered pairs. So when they tell us to find 4 solutions, and we come up with 4 different values for X, 4 possible solutions would be the order pairs that you've created. Okay, the first coordinate order pair, the first coordinate would be -1, 2. So this, remember, this is your X and Y. 0 and 1. 1 and 0. And 2 and -1. Okay, for the independent practice, you know how to do 3 to 6. They're asking you to find 4 solutions for each equation. Write the solution as order pairs. So let's say you're going to choose whatever value you want for X, such as you can choose pretty much anything that you want here at this point, but it's going to change the value of your Y. For example, if you chose -1, -5 times -1 would give you 5. Okay, so it would be -1, 5 would be your first answer, right? -1 will be your X, 5. Okay, that's one solution for this question, but we're asking you to find 4. So I need 4 order pairs. You could also choose 0. If you make this 0, they're both 0, 0, 0, right? You could choose 1, and it would make this -5. I'm sorry, it would make this -5 and 1, so 1, -5. Okay, so go ahead and choose 4 for each one. So your answer should consist